cache is without doubt one of the most important things you can have in a processor. It really does improve the performance of your system. Let me show you how it does it. Now I've got a little diagram here in the notes. You can see the diagram here, and I just want to talk you through the basic process that you actually have here. Because the CPU, here we've got the CPU sitting over in the corner here. Here we've got cache. So we've got the CPU and we've got cache. And obviously we've got RAM sitting over here. Remember, everything that the CPU does has to be in RAM for it to actually process that particular piece of code. Now this is the magic device. This device sitting in the middle here, the cache controller. Because the cache controller does a very, very good job for the CPU. Let me describe to you the basic process that happens. I'm actually going to do this on a separate piece of paper. But the diagram's the same, so you can just annotate your ones in the notes if you want. But I'm just going to try and clear some of it up. Right, we've got the CPU here. We've also got cache sitting here. We've got the cache controller, so CC for cache controller, and we've got RAM. Now I want you to imagine, first of all, there's two different types of cache. Or let me rephrase that. There are two jobs that cache does for you. First job is it holds on to commonly used instructions. As a classic example, imagine a picture on a monitor, and you've got the sky and the land. And up in the top corner, you've got pixels. Obviously, the monitor is broken down into lots of pixels. Now, if you've got a simple picture of the sky and the land, then there's going to be a lot of blue in that picture, isn't there? And there's going to be a lot of green in that picture. Now, the processor has had to work out the colors for each one of those pixels and provide that information to the graphics card. Now, it could, if it wanted to, do the same calculation for every single pixel. Or it could say, hang on, that's a pixel, okay, but that's the same. So I'll just use that same calculation again. There's not, same calculation again. It's a bit like me saying to Victor, sorry, what's 2 plus 3?
5.
5, okay, cool. I've got another question for you. 2 plus 3?
5.
Okay, I've got another question for you. 2 plus 3?
5.
You see what I'm saying? There's no point in going through the whole process of just remembering that stuff again. So why not just store it somewhere so that if anybody else wants that answer, it's immediately there for him. And that's one of the jobs that cache does. And that's the most simple one for me to describe. But there's a second job, which I just want to quickly run through. Yep, go for it, Michael.
To how much detail does the cache, sort of what level of detail does it go to? Well, remember, like, say, a graphics detail equation to work out some graphics, or is it just basic operations that tend to be repeated often?
You've hit the nail on the head. Basic operations, or even complex operations that tend to be repeated often. What the cache controller's job will do is it will look at certain information that's going from one thing to the other and say, hang on, this is the same bit of information. Why do I keep giving him that same question? Let's just give him the same answer back. There you go, there's the answer. You with me? So it depends. Yeah, it can be complicated, but the key is commonly used instructions or commonly used calculations. Cool. Second thing you can also have with cache is it can do something called reading ahead. Let me just describe to you what that means. First thing, let's pretend we've got our CV open in Microsoft Word. So our CV is open in Microsoft Word, and files are broken down into certain chunks inside RAM. We've got little blocks of RAM. There's generally 64 kilobyte blocks. So I'm going to put that annotated on my RAM chip here. Now this is what the cache can actually do. It's a very clever system. As I say, this is read ahead cache. The way it works is, the first thing the CPU does is the CPU, when it tries to open or make use of this particular file that's being stored in RAM, is it says, excuse me, Mr. Cache, do you have this file that I need? And of course, cache doesn't have it. So it says, no, sorry. And the CPU goes, no problem. So that's the first operation it did. Then the CPU goes, no problem, I will go and check in RAM. And of course, it finds it in RAM, because there's the file. And it can only bring over one chunk at a time. So it grabs hold of that chunk, transfers it back into the CPU, and starts working on it. And this is where the intelligence kicks in, because the cache controller makes a very, very good assumption. The cache controller says, oh, hang on. He's just used that particular piece of code relating to that file. Isn't it logical, therefore, that he's going to need to use the rest of that code at some point very shortly in the future? Obviously, bear in mind, guys, this is happening lightning fast. But it makes that assumption. It says, okay, perhaps it's going to need this particular piece of code. So this is what the cache controller does. The cache controller grabs hold of that chunk, grabs hold of that chunk, and grabs hold of that chunk, and moves them into cache. So there they are. They're now sitting inside cache. So when indeed that does happen, in other words, the CPU now needs to find the next piece of information, where did the CPU ask first?
Cache.
Cache. So it says, excuse me, Mr. Cache, do you have this file I need? And Cache says, sure, there you go. Goes, cool. Goes for the next one.
It doesn't come to the RAM again.
No, because it doesn't need to, because the cache controller has moved it into the RAM, into cache for him. It then gets the next one and the next one. So it saved it from having to go to RAM at all. It's just now able to go to cache. Now, I'm guessing a few of you are thinking, well, okay, it's all well and good, but why? Why not just go to RAM? And there's a very simple reason for this. Because cache is very, very fast. Much faster than RAM. RAM is still fast, but it's not quite as fast. So we'll just put very fast. Cache, very, very fast. RAM, just very fast. If you compare it to a hard drive, it's very fast. But compared to cache, nowhere near as fast. So two main roles of RAM. One, to store commonly used instructions and commonly used calculations. Two, to perform this reading ahead task. Bear in mind, guys, this is just a concept I've described to you here, using a Word file as an example. Don't think literally with this, but it's grabbing hold of code that you're likely to need very shortly, and it pulls it into cache so that when you go to look for it, it's there. The CPU doesn't care how it got there, it's just there. And the cache controller is doing that actual job. In reality, you're never going to have the whole of a Word file inside a CPU. It simply wouldn't fit. Go for it, Andy. You got a question?
Yeah. Is there an instance where a computer would only use whatever they use for cache as memory, if it's so fast?
Excellent. Brilliant question. What Andy is saying is that, correct me if I'm wrong, Andy, but I think this is what you're saying, is if this is very, very fast, why not just use that for all of your RAM?
Yeah.
There's a very simple reason for that. A particular Intel chip came with 128K of cache. Okay? Exactly the same chip. Identical in every way apart from the cache. So in other words, it had more cache. So this is another chip with more cache, but was identical in every other way. It just had more cache. Was £100 more expensive. So for 128 kilobytes of cache, it's 100 quid. That's just an example. That's the Celeron processor, incidentally. The Celeron processor is identical in every way to a standard P2. It's just got less cache. And therefore it's cheaper and able to compete with AMD, who were selling their processors cheaper at the time. Not so much anymore. Intel and AMD are the same price now, because AMD got better. So Intel could no longer have the premium chip, because they were now just as good as AMD. So yeah, that's your answer in a nutshell. It's lightning fast. It's what's called static RAM. We're going to look at it in the RAM section in much more detail. So I'm going to ask you to trust me for a second, and it's a lot faster. I'll explain why it's fast later on. But cost. Bottom line, cost. You could have, if you want to, 512, well, you couldn't really, but say pretend you could have 512 megabytes of cache. Cool. That's £250,000 for that PC, please. And you say, yeah, right. But it's very fast. Don't care. It's a trade-off, isn't it, between cost and speed.